Thanks everyone for joining, and thanks a lot for inviting me here for this session as well. And everyone, it's a weekend, but still you are here, so that's pretty nice. So what we'll do, we'll get started, and I will just quickly put the agenda and so on and so forth in place. Now, if I'll just put my LinkedIn profile as well in the chat window, in case you guys want to have a look at this. My name is Shivam, and I basically work in Azure. And I have also started my company called as TechScalable. And the agenda for the day is regarding MLOps. So what we are doing is we will be training one custom AI solution, and we'll be deploying that custom AI solution in the IoT Edge. That's my Raspberry Pi. So I'll just let me check if it is visible or not. Just give me a second. Okay, so if you can see, this is one of the Raspberry Pi over here, which is plugged in. Hopefully this is visible, this one over here. And yeah, it's still plugged in. And this is the one which we'll be using just to have a look at what we are doing and so on and so forth, which wire goes where and so on and so forth, right? All of those things we'll be doing. So let me quickly explain what we are doing in as the agenda for the day. I'll share my screen as well so I can walk you through all those things. Now, the overall flow which we have is we have a lot of things. First of all, we will be covering a lot of things as such. I'll be switching back and forth between the screen sharing uh, and the video, so we can look at the IoT devices as well. So I'll just do it over here properly. Okay, so now if you can see my screen, I'll just walk you through the definition of MLOps. And once we have seen the definition of MLOps, we will be going and we'll understand how to do it, and we'll set the agenda as well. So if you just read this with me over here, the machine learning for DevOps or MLOps is an organizational change that relies on a combination of people, process, technology to deliver machine learning solutions in a robust, scalable, reliable, and automated way, right? There are a lot of things over there. Okay, so I'll just walk you through what we are doing. So if I zoom out and if I just go to the diagram, this is what MLOps looks and means as such. So we'll be exploring, we'll understand what is this, what is the meaning of exploring, experiment, develop, operate. So if you can see, we have so many subparts over here: problem definition, data acquisition, EDA, project assessment, model selection, feature engineering, tracking and validation, testing, automation, model serving, drift, monitoring, retraining, and the monitoring of the entire infrastructure as well. So we'll understand what is this. And what we are doing is something which I think I have kept it open on my secondary page. And if I can find the correct thing over there, so something like this is what we are doing. I'll just summarize it once and then we'll jump into the individual things over there. Something like this. So we will have the IoT Hub in the cloud, and we'll understand what is MLOps. We have the IoT Edge device with us, the real one, and we will be setting it up. We'll be connecting the IoT Edge device with the IoT Hub. We will be training one AI model, and then we will be creating custom AI modules for IoT Edge, custom IoT Edge modules as such. And then we will create the MLOps pipeline, and we'll see if it works, right? That's what we are planning. Okay, so let's get started. Now, the very first thing which I want to do is I just want to stop my screen share so we can all zoom in the video, and hopefully the video will be in full screen now. So I'll just move this closer. So what I have done, if you can see this Raspberry Pi over here, I have this Raspberry Pi 4 Model B. This one is having 4 GB RAM. The one which is plugged in is having 2 GB RAM as such. Now, if you can see, these are the USB ports over there, if that's visible, and that's the Ethernet cable which I'm using right now. It is plugged in with my laptop. Wi-Fi modules are also there that can also be used, and that's the camera module. This one over here, if that is visible, this one. The camera is right now in my hand. It's got unplugged. So this is the camera over there. You can use other modules as well, but this just comes, which we can put in there. And apart from that, the power socket is here. That's the power socket, this one. And then here is where the SD card goes, the SD cards. So that's the storage of the IoT device. So this is a Raspberry Pi. That's the IoT device. That's what we are thinking about. And so what do you need to be able to do what I'm showing you today? What you basically need is a couple of things with you. You need the SD card readers as well as these micro SD card readers, something like that you can have, or something similar to that, right? Just give me a second. Okay, so I have multiple, and you need these SD cards as well. So the SD cards which I have right now, one is plugged in. It's of 16 GB is plugged in right now. That's 164 GB SD card. Uh, it is having Ubuntu over there. So I just mark it on the SD cards because I forget after a few days that in which card what is installed, because it takes a little bit of time to install all of this. So I'll show you how the installation is done of the operating system as well, but it goes in this card over there, this small one as such. Right? Hopefully that is visible. Say yes in the chat if you can see all these things. If it is visible and you're able to follow me over here, just say yes in the chat, right? Over there. Right? Okay, great. So now to get started. So what we are doing is I'll share my screen as well. I'll go back to the video when required. So let's go back to the screen. So now what we are doing is I'll show you the Raspberry Pi imager. So you need something like this, a Raspberry Pi imager. And what happens is you need to put in the SD card in the in that in the SD card reader, and you just have to plug that in, right? So find any slot, plug that in. Now the operating systems are available here. So the one which I'm using right now is this one, OS Lite 32-bit. I also have this one as well uh, installed in one of the cards. And if you are looking for any other operating system, you can also go for that. You can simply go back one tab, and here you can find the other general purpose operating system. So I have this Ubuntu also in one of the SD cards. We are not using it today. Uh, Overall logic doesn't make much difference apart from few of the commands which we have. So you can use anything. However, you have to get it installed. Okay, so what we generally do, you put this in, you plug it in, and then you select your operating system, the one which you are looking for. We are using the Raspberry Pi right now. And then once you have done this, uh, once this is plugged in, it will be visible in the storage, select storage there. Then you click on this icon over here for configuration purpose. Now, I think I won't be able to zoom in here, but hopefully this will be visible. So you can see, you can set the host name from there. You can simply specify the name of that. So the name which I have is, I'll just show you. I'll connect to my Raspberry Pi, which is plugged in right now. So the one to which I'm plugged in, it's basically called as, the name is here. I'll take an SSH of it. It's plugged in with the Ethernet cable over there. Wi-Fi is also possible, right? If I can remember the username and password. So let me do that. It's Raspberry Pi at the rate Raspberry Pi.local, I think. Raspberry Pi.local. That's the name. Okay, great. So great. This is the one which is plugged in right now. And now, right? So now I can hear my voice back. Let me mute everyone. Hang in. Okay, everybody's on mute. Now check this. So you set the name by which it will be detected on your network, and then you can put other things as well. You can enable the SSH. Sorry, I'll just go up. Okay, so if you can see, we can enable the SSH, the username and password. So for example, my user is Pi right now. That's the name of the user, the local user. Now that's my Wi-Fi. It's detecting it because I think I'm connected on the same Wi-Fi right now in my laptop. So it must be getting it from there, over there. So that's the Wi-Fi. So in case I select that, then I don't even need the Ethernet cable, and the Raspberry Pi will be, you can say, detected over the Wi-Fi over there. So you can specify the SSID. You can do it later on as well. It's not that it's always has to be done from the imager. We can do it from the config as well later on. Any local settings which needs to be done, play the sounds and so on and so forth, all of these things, you say save and you simply click on write, right? So it took me around 3-4 hours. I already had it with me, but the first time which I remember when I did that, it took me around 4 or 5 hours because this SD card reader and also the SD card is of it's a normal one. I don't know what's the best which is available as such, but it had some X amount of Mbps speed. So it took some time, right? Okay. Now, anyways, once you have done that, right, that's the first part. You have to do that. Now, then you need so I have this box as well. You plug everything in. You plug in the wire, the power supply, and you connect it with your some device. You don't need your laptop. You can also directly use any monitor, and you can also put in the keyboard directly as well. But that is just too much of work. So I did the SSH part. Okay, now if I let me see till where I have taken you. Okay, so now let me just explain a couple of things. So the next thing is, so your Raspberry Pi is now connected. It's detected over the uh, some sort of network, right? As such. So this is the Raspberry Pi over there. Now we have to sort of connect this with the cloud. So in Azure, we have this solution which is called as Azure IoT Hub. Azure IoT Hub the is the default or de facto solution which we use when we work with IoT scenarios. So what this IoT Hub can do, it can register all these devices and it can also send the commands back. So today we would like to do that. We would like to push the images there. We would like to do something inside that Raspberry Pi, which is having that camera module. So that's the camera module which we are representing like that. So this is the camera module over here. So how do you do this registration, right? You have to make the IoT Hub first in the Azure portal, and then some registration is required, right? So like this. So if I take you to my Azure portal, so in the MLOps pipeline, we are doing it for the IoT Edge. So we are registering the Edge first, right? And then we'll understand the entire pipeline also on the way. So I'll take you to the Azure portal, and I have it open somewhere here. And I have this IoT Hub. You can make a new one as well. So if I just quickly do that over here, you can simply you need Azure subscription basically. So look for IoT and look for the hub over here. Say IoT Hub like that, and you create one. Right, just fill up the page. It's based on Apache Kafka. It is having the topics over there. So data goes inside those topics, but everything is abstracted. You don't have to take care of it. Just give a name, region. So the region which I am going for is East US. So my uh, device is there in East US right now. Okay. So once it is deployed, it looks like that. So if I click on it, sorry, not this one. If I find it, it's in my resource group somewhere. So that's the one. Okay. So that's the second step. Now, third step is you come to the IoT Edge over here, and you click on the add IoT device like this, and you say, let's say MyPi2. MyPi1 is the name which I gave earlier. Now, we can do it manually as well. We can also have a bulk registration of the devices, like when you are working with maybe some sort of Fitbit band or maybe some sort of IoT device which is produced on a mass scale, then also it makes sense. So for now, I will just say save. And then the next thing is we refresh the page and click on the MyPi2, and you need to copy the connection string, let's say from here. So what we are doing is we are trying to connect the IoT devices with the Azure Hub. Now, if I just open one notepad and if I save that image, that key over there, let me just do that here. That's the connection string. Okay, now I also have few reference links for all of you. Wanted to share this. I'll just share it in the chat window. I'll put it in the end of the session as well. But whatever I'm showing you or whatever you need to know is available on those links. You can go through those links and you can even go way beyond what we are doing right now. Oh, I should have numbered them, but it seems they all went in a bulk over there. Hopefully you can copy them and put them in a notepad with you. Okay, so that's MyPy 2. Now in MyPy 2, the next thing is you go back to your IoT, to the Raspberry Pi, which is the IoT device for us, where to which want to do the MLOps. So now we need to do a few installations here. You see this? So this is a microcomputer, this one, right? So we need to do a few installations over there to be able to get it to work with the cloud. So few things needs to be installed. First, we need a Docker engine to which can be used over there. So the Docker engine which I am going to use is called as Moby. And this is the link which which I have already shared with you, but this is the link which I would like you to follow to be able to connect your various type of devices to the cloud. So for example, for Ubuntu, follow this. For Raspberry Pi, follow that. So we are doing the Raspberry Pi installation, so we'll follow this. So what we do is we install a few packages first. Then we install the container engine in the Raspberry Pi device or in the IoT device over there in this one. So it's pretty lightweight. This device is also not having much of RAM. The one which is plugged in is having 2 GB RAM over there, but it is able to handle the workload which we are running there. So this is the Moby is the Docker engine which we are installing over there. So we can run the Docker. Everything is containerized. Everything, all the modules are containerized. Everything which is running will be containerized. So you need the engine to be there. So you install this first. This one, I have installed this over there. It takes a minute or two to install for the first time. We can do it one more time as well if needed. Just copy paste and run it. Second thing is you need to install the Azure IoT Edge. So first, you need the Docker engine. So that's the Moby. That's what we are using right now. This is the IoT Edge, uh, which is basically all the packages and all the dependencies required to run that. That's the second thing, which is there over there. Now, once you have done that, right, the third thing is you need to take your connection string like this, and maybe I need to zoom in here. These are my dummy accounts or demo accounts. So anyways, I'll delete everything so you can have a look at this, but I'll just show it to you how you need to do this. So you put it there, you put it like this, and then you just copy this over there like that. And you go back to your device and you put it here and you run it. This will say that it is already existing. So that's not an issue. That's great. It's already existing over there. But if I and then this is one of the apply operation. I can forcefully apply as well. If I want to, let's say, reapply, I can also put this reapply. It will apply what I just copy pasted there forcefully one more time, right over there. So which is okay. We are okay with that. Now this is a system check over there. The system status. And let me just start doing that over here. So I can remove sudo. I went in as the root user right now. And uh, just give me a second. Let me see, did I uninstall it before the demo or what did I do? So, okay, things are running. That's fine. Things are running. Okay, now, one of them. So, okay, what is this going on? So basically one of them is likely to fail because it needs some DNS configuration, and I'm using the default DNS configuration of my of which is 8.8.8.8. So I don't have I didn't want it to do anything else. IPv6 has also failed, which I don't want that to be there right now. And all of these things you are also likely to it may fail for you. It doesn't matter for what we are doing today. But if you can see that it is checking all the configurations over there as such, and so the identity service is running okay. The identity service for Azure IoT is running okay over there. So it is looking for which ports it's connecting on. It's connecting for other things. DNS server and all that, we don't have it. We don't want to configure it. And something is still going on. Okay, some ports. Everything is fine over there. So things are running great. Okay, so this is basically over here. And I can also do an IoT Edge list. It should say, uh, I think it's still printing something out. Sorry, let me just copy that one thing. And the, okay. So this is showing something which is already deployed, these two, which I will show you how I created that around 30 minutes back. But this is the one which will be there by default for you in this point in time. As such, it should, and it takes time, right? It particularly takes time. Like it will take maybe 5 or 10 minutes. Something initially there will be nothing there. After some time, you will have you can go and see the images like this. You can say Docker images, and you will see that some of the images are getting pulled. And then after some time, you will be able to see the Docker containers also running. So there will be two containers which will be running, the agent and the hub over here, these two. These middle two we'll see how are they there and why are they there. Okay, so let me summarize everything. What have we done? So if I just take you back to my whiteboard, we took the Raspberry Pi, we connected that with the cloud. So we took the connection string from here, and we went to the Raspberry Pi and we did some configuration in that, in which we installed the the Docker runtime as such, or the Docker the engine, the container engine. Let me say the container engine as such, movie, and the IoT Edge for Azure. And then we took the connection string, we installed it over there. Once you have done all of this, it should be saying something in the Azure portal. So if you go to this, and if I take you back to my previous one, which is registered called as MyPi1, it should be saying something healthy or not healthy or something running over there. Uh, okay, let me see. It's not unable to get the modules information. So let me just fix that. Just give me a second. So it was something I was playing with. Okay, now that's fixed. So it should say if we refresh that, something is going on running as such. So these two are running over here like this. So Azure Hub and the agent is running there. So these two containers are right now in this Raspberry Pi here. This is the agent, and that's the hub. Let's say the hub. So hub is supposed to connect to multiple agents. We only have one agent, so that's, you can say that this is the agent. It is running. Both of them are running on the same machine right now, as such. Okay, so if I take you further. Okay, if you have questions, you put your questions in the chat window, right? Keep it. Just put that question in the chat window. I'll take them on the way, or otherwise we'll take them in the end of the session as well. Now, okay. So we have done one part of the setup. We were able to connect the IoT device with the cloud. Now I would like you to see a couple of things. Now there are a lot of devices which are there. You have to look up like this. You can say Azure uh, IoT device catalog, something like this. Uh, Catalog over there, and you can look for these devices. So the one which I'm using is just like a non-production version, sort of Raspberry Pi for your learning purpose, but there are industry grade or industry certified devices as well, which you can, and this list is available here. You can find this list. You can just Google for it, and just I'm putting the link in the chat window like this. So whatever you're looking for, you can look for something like that. So these are devices which are built on Raspberry Pi, but for healthcare industry, they have other things. For retail industry, some other devices are there. Go and check in the other tabs over there, whatever you are looking for. Okay, now these are the certified devices as such. Now, what we are going to do is, let's go back to that MLOps part, right? What is MLOps? Uh, and we need to understand MLOps as well. So we can finish everything over here. The steps quickly after purchasing the device till the OS installation. The link is here. I'll give you the link which I shared. I followed these steps over there. These ones over there. It's in the chat window. So those are the ones which I have used. This ones. Okay, now check this. Check this. If I take you back to MLOps, now see, there are a couple of things we need to understand. MLOps is different from DevOps. It's not a normal DevOps pipeline. It's not what we do in CI/CD as such, because of a couple of things. First of all, machine learning comes over there, and the data science is not a linear process. It's more like a life cycle. It goes back in an iterative loops as such when we retrain the solution. So the we have to understand the differences which are there in machine learning for DevOps, and we will be thinking about all the details over there. So what I have done, I don't want to waste your time, but I still have few of these slides with me where which I will use for just explaining a couple of things. It's the wrong end of the slide, so I'll swap the screen. So if I take you back to the definition of MLOps, it's basically the combination of people, processes, and the we can say technology, people, process to deliver the solutions. Now this is what we have over here, right? Now if I find uh, if I can find that, uh, basically, yeah, okay, great. Okay, so problem definition, data acquisition, exploratory data analytics, and project assessment. These are the things which we will be understanding. And then the second part, which is over there, is the model selection, feature engineering, tracking, testing, automation, uh, model serving, drift, and so on and so forth. Okay, now looking at this diagram, it doesn't make much sense, right? It is something, if you already work with MLOps, it will make sense to you. Otherwise, to break it up, or if you're also thinking just like me, when I maybe learned it for the first time, like what is going on, what's the meaning of it, if you're also thinking on the same lines, then let's understand, right? So I'll take you back out to my whiteboard, and I'll take you to a small journey. We'll understand a couple of things over here, right? And on the way, we'll understand the process and the concepts. So first of all, MLOps is not like any normal application, you can say, development or deployment as well. It has significant changes, which we will be understanding as soon as I can find my cursor. Okay. So let me share my screen one more time. Okay. So hopefully my screen will be visible, right? Uh, I think somebody's camera got enabled. I can see a black screen there. Okay, so now check this. So it's not like application development, and what happens is everything starts from the business needs as such over there. So when you talk about business needs, your your business will basically to solve that business need, you will also be looking for some sort of you can say you need data to be able to solve that business need. So first thing is business need as such, and then we also need data to be able to meet that business need. So the very first thing, if I take you back to that diagram, you see this, and if I go 2 steps back, you see this, the problem definition and the data acquisition. That step starts over here. So when we talk about data acquisition, we have to acquire the data. Engineers will help out the data scientists to be able to acquire the data. Now, data might be available in various locations. The data might be available in lake houses as such. This is something which is very you can say popular these days, lake houses. And if you find me on LinkedIn, right? I have done many sessions on lake house and so on and so forth. You can find those from the previous post. Basically, here we have different type of tables: bronze, silver, gold, and we keep the raw data, silver data, gold data, aggregated data. So you will be getting your data from the data will be acquired from various locations. The data which is acquired might be acquired from some streaming sources, or might be acquired uh, from some batch sources. The data might be in data lake, right? This is the replacement of HDFS in the clouds, Azure Data Lake, or it's in from the other clouds as well. Data might be in different environments as well. It might be relational. It might be uh, let's say semi-structured, it might be unstructured as well. It might be having, it might be a massive parallel warehouse, like something like that. So there's a solution which we have in Azure called as dedicated SQL pool. It's a massive warehouse. Uh, it does parallel processing. It's very similar to MapReduce, some that type of thing it does, but it's a relational warehouse. We use it for reporting purpose. We do descriptive analytics with it. Okay, so data might be there. We may have to get the data from that location. The data engineers will help us in getting the data from maybe, sorry, let me say the data might be present in on premises. That's your on-premise office building. That's some branch office over there. This is a express route over here. In Azure, we have the fiber optic connection to the cloud, which is called as express route. So this orange thing over here is that express route. So data might be present over there. You may have to get the data. The data engineers will get it from on-prem as well. That's just one representational Azure VNet architecture where various things are there. Okay, so we may have to get the data from on-prem. Now, this is a very popular tool in Azure called as Azure Data Factory. Azure Data Factory is a service by which it's very similar to, this is actually SSIS in the cloud, SQL Server Integration Services. This is also, it's the one by which we do ETL and ELT. So we extract data from on-prem, we transform, we load, or we load first, we transform after that. So these are two type of pipelines we create. So let's say the data which you require for solving the business problem is in AWS. So somebody has to get it from there, right? So if I take you back to that MLOps definition or the MLOps step number 1, you see this data acquisition. That's what we are thinking of right now. From where are we going to acquire the data for the purpose of machine learning or for the purpose of creating the model which we want to deploy as such. So it might be in AWS, it might be in GCP, it might be in my portal, my subscription, you want it from there. It might be in your other subscription as such in your company. It might be in the same subscription also, which needs some transformation before it can be used. So these are all those locations over there. Now, one more thing. This is a batch ingestion of data. What happens if you are getting a stream ingestion of data? So I just showed you IoT Hub. IoT Hub was the one which was used for connecting with the IoT solution over there. Remember the IoT Hub which we just connected with the Raspberry Pi. So the data might be the data on which you are training the machine learning model might be coming from various locations as such, from some maybe from a Raspberry Pi today, or it might be coming from some sort of you can say it might be coming from some IoT device as such. I'll just pull one of my favorite image which I use over here. So you see this, it's called as a rod pump. So the data might be coming from these rod pumps as well, somewhere remotely placed in some remote location. Sensor information is coming, temperature. You are getting some sort of vibration, noise, temperature, pressure, friction values. If the friction goes down, or if the pressure it goes down, it means that this casing broke. So many things. The data might be coming from the devices over here. So as part of data acquisition, or it might be coming from Twitter as such, or it might be coming from any other you can say event-driven scenario over there. So the very first thing which is there as part of the MLOps is this data acquisition. So that data acquisition is coming from all these sources, on-prem, cloud, streaming, batch sources, and the data engineers will help you out in getting it from that location over there. Now, once you have done that, once you got your data, once you got your data, now you know the business problem as well. You understand the business problem. It's very important that you sort of understand that. And if my screen got stuck, so I'll just move it around. Okay, let's find you today. So in this journey with me, that's where you are. You see that one, the one which is having the star on top of it. That's where you are. That's the one today. Okay, now, so you're a data scientist. You got the data, which the data engineers helped you out over there as such, and you got the data. But the problem is, before we can give the data to you, the problem is that we cannot show the real data to you, because if we give the real data, you will breach the privacy of the customer. So real data will not be, you can say, we cannot breach the privacy of the customer, like unlike some of the social media websites which we can name as such, which can do that. That's not part of responsible AI. So what we do is there is a concept in Azure, or there is a concept in this world, not in Azure as well. It's just a normal concept. Azure also follows that. It's called as differential privacy. So in differential privacy, what we do, the data which we acquire, right? So I have now sort of jumped into these steps. It's not written here. It won't be written there, but these are some of the intermediate steps which are there, which you have to, which we'll just understand on the way, right? We'll go in depth. We'll see what we are talking about. So the concept is called as differential privacy. Now, what happens is the original data source which you have, as part of the responsible AI principles, we will not be able to, uh, we should not you can say look at the data the way it is. So what we do, we add some noise to it. So there is in Python we have these libraries called as smart noise packages over here. See this smart noise packages. What they do, they add noise. We have values. Like in hyperparameter tuning, you have some values by which you control it, right? Similarly, here also we have some values by which we control it. There is a called as epsilon value. Its value can be greater than 1 also, but the best value is between 0 and 1 over there. Something in this point which you can see here. That's the best value of epsilon. So what it does, the smaller the value, more the noise will be there. That's what you have to remember. Now,
Is it
so
similar to learning rate in the stochastic gradient descent?
that is it's a parameter. For example, LR, by which we are controlling the learning rate. Similar epsilon value will be there by which noise will be added. So if I give the value smaller, more noise will be added as such,
Oh, okay,
like this,
got it.
like this. This is less value, less noise.
Would we be
Now,
able to retain later on in case?
retain in the sense original data.
Yeah, through mathematical computations. Yeah.
The answer is yes. You have okay. So this is, let's say, imagine this is the data which we have in the data lake, the original one. Nobody can see that, and this copy is still available. So this is the original one over here, and then on top of it we have made the noise, and this is the data which is secure. So we have the original copies of the data as well, which is just not available for anyone to look at. But yeah, we
Yeah,
have that original one.
I was referring to reverse transformation, not referring to the original data source, but reverse transformation.
It will not be possible because that's also you can say thought through. Like for example, if you, let's say, if there is some sort of multiplication which I do, if I divide by that, I get the original value out, but that doesn't happen over there. They make sure that even if you that this is done in a manner that you will not be able to get the original data if I give you the secure data.
No,
So
no,
no, they
I
thought that.
understand all those privacy aspects, but in the extreme situations, there will be some cases wherein we'll have to perform reverse transformation. I was referring to those exceptions, not the normal responsible AI privacy part of it.
Okay, then why don't you use the original data if you need that?
Okay, I
You can
mean,
use this
there
also, right?
will be information security violations when we are trying to
Okay,
access that part. Anyways, we'll talk later on. Yeah. Anyway, thank
right?
you.
And okay, so now check this out. So we have this secure private data now, the one on top of which we have the noise as such added. So this is the one which you have. You don't have the original data over there, which might be a patient's secure, you can say, some information of the patient as such in your OLTP databases, which is what we are referring to in this case over here. Okay, so what do I have now? I have this secure data, or I have this private data. This private data is the one which is having some noise added to it. Now, on top of it is the next thing which comes into place, which is called as EDA. So if I come back over here, and if I just put some cursor on top of it, or some identifier on top of it, this is where we have reached. This is the EDA part over here. So we have to explore the data. We will be understanding, we'll be creating hypothesis over there, we'll be exploring the data, we will be trying to understand that based on the uh, you can say based on what we want to achieve, can it be achieved on this data or not? So in this part, we'll be having various type of charts as such created in that location over there. So let's say pie chart, box plots, scatter plots, and so on and so forth. Something very important which happens over here in this point is that we decide that do we need some more data to be able to do that. So let's say from the data which we have acquired, what we have right now cannot be achieved. We need more data. Something goes on hold, or the project is on hold right now. We need to gather some more data. On this data, that problem statement may not be able to achieve. Or the second thing over there, which you can see is yes, the business outcome can be achieved on top of this. So once we understand this, like can we achieve the business outcomes or not, then we will be able to go to the next phase over here, where we are thinking about the model selections or the feature engineering or the tracking and the validation and the second phase. So whatever we were discussing till now was in the part one. So this is the phase two over there, which starts now. Okay. So questions in the chat, or you can ask your questions now. Let me know any thoughts which comes to mind. And is the first part clear, or are we able to uh, understand what we are covering here? Or am I going very fast or something like that? Then please let me know.
No, no. Your pace is absolutely fine. I just have a simple question on how do we come to the conclusion on whether this data is enough? Are you referring to the distribution of the data or new data points on another feature targeting the target variable? Or
I
we are missing
was
out some points in the middle of the distribution? Sorry.
okay. I was looking for the hypothesis testing over there. The hypothesis which we are doing to be able to on this data, which may be on the you can say on the features which you have uh, in the data, the other attributes which you're talking about.
Yeah, the number of features, or is it inside the features? Are we missing any points in the distribution of the features against plotted against target variables?
The come back with your question. So I think are you talking about data cleaning right now?
No, no, no. About the sufficiency of the data. I mean, we can have a discussion later on. I would not,
Sure,
expect to get all the answers right now
sure,
because this is
sure.
still evolving. It's a big sea. All the
Okay, sure. So that's then hang in over there. Okay, so overview of
sure.
first part. Right. If I just give an overview of the first part, it's basically this: the problem definition, the data acquisition understanding, EDA, and the project assessment over there. This is the first part. So for problem definition, we that's where the business came into picture. The data acquisition happened over all the pipelines which we had and data factory and so on and so forth. EDA is what we just thought of, and now we are ready to move to the next phase over there. Okay, so before we can go to the next phase, we now will be able to. There are a few questions in the chat window. The without EDF and the EDA is you're doing the EDA over here. Uh, okay, we'll take those questions on in the end of the session. Let's see if you get all your answers. Notice this now. So this is the data science lifecycle over here. Now, if I zoom in over there and show this to you, right? This is the diagram which you have seen in all the locations, right? In Microsoft's documentation or so and so forth. This is the one which they use in all the positions. So now, what is the life cycle of the data science? We have four major phases over there, and which all of you guys are talking about. So let's hit them. So the first thing is, let's say, business understanding, which we have here, the first phase. The second one is the data acquisition and the understanding. Data might be coming from all the locations, on-prem, cloud, big data, structured, unstructured data, and so on and so forth. We got all of it. Now we are jumping into the modeling phase over there. As such, now feature engineering needs to be done, transformation needs to be done, feature selection needs to be done, the algorithm needs to be selected, the model evaluation needs to be done, and we also have the deployment phase over there, the four phases. And now these we can jump between these phases as such. So now I would like you to look at, I'll share one link in the chat window over here. And that's what I'm trying to look for in my secondary screen. If I can drag it here. And if I walk you through this one, and if I can zoom in over here, you will see that. Let's go through these ones, right? Or let me just open this in Edge so I can write on top of it. Just give me a second. Let me open that in Edge. So okay. So check this out. Right. So let's find the pen and check this with me. Now, so what do you want to do? That's where we are over here. Now, if we just look at all of these various you can say what you want to do over there. If we just break it into pieces, let's say if you want to extract some information from the text over here. Uh, First, let's say, then some text analytics over there, and then okay. So this is not exhaustive. This is just one, you can say, algorithms which Microsoft Azure was able to put into one page, or where in that PDF they were able to fit in one page. We can do anything in Azure. Like if you want to work with your own favorite frameworks, feel free to do that. You can use TensorFlow, you can use PyTorch. So right, but let's have a look at this. Now, for example, what happens if you want to do we want to predict the values over here, the second thing. So this is where we have the regression. And let me just say regression analysis. You want to predict tomorrow morning stock price, then you do this. Third thing is, let's say you want to discover some structures. So then clustering comes into picture. Then if you want to do any anomaly detection, you want to find unusual patterns in the data, want to find that the vibration has gone, the vibration is a forced vibration, and you want to find that forced vibration because that vibration is being caused due to a micro tear or some sort of major tear which has been done in the conveyor belt. So you want to find that anomaly over there. Okay. Now predict between several categories. So multi-class classification as such, and the prediction between two categories. Then we have the two-class classifications over here. And if we want to classify some images over there, then we have image classification. So this is where your CNNs and everything, the VIT or the CNN will come over here. Now, if I just minimize that uh, as such, and if I take you back to my data science lifecycle over there, and if we just zoom out and we understand what we have in the screen, which seems to be erased. Uh, so let's see this now. Just give me a second. Okay, so check this. Now, in case I have, and I'll take you to my Azure portal as well on this point. So we can look at this from Azure's point of view as well. So I deployed this machine learning service just before we started with the session. I will keep this open over here. So this is the custom AI solution by which we create custom AI. That's what it does. So what happens over here is, now we got the data from various sources. Now in the if you think about Azure machine learning as such, there is a concept called as data store. It's very important in MLOps that we version anything and everything which we are doing. For example, uh, the data which we are getting, we might be getting from some relational data location like that, like Azure SQL, or we might be getting some data from Postgres as such, or it might be coming from a data lake, which is basically uh, called as it's a edge replacement of HDFS, or you are getting the data from Postgres or something like that. So various locations are there. Now, what we will call these locations as data stores over here. So these data stores are simply these data stores on the left hand side of the page here, these ones. Now, the next thing which we do is we would like to version our data sets uh, because the data is everything in, uh, you can say, in the process of machine learning, data is very important. Now, if you are doing any type of transformation on the data, imagine originally you had some attributes as such, T1, T2, let me just put as, let's say from various tables you are getting some attributes over there. So you have tables T1 and T2 tables. And if my whiteboard can stop getting stuck, okay, let's say, and then you had few attributes. Some attributes are there. This is 3 and 4, and finally you merge them. You did some sort of, you versioned it. You created another data set on top of it. So what we want to do is we want to version it and we want to save those versions. Like, okay, T1 is the one, and then the metadata about that. Okay, so what do we have over here? So here we may have some attributes over here, let's say like this, and maybe over here you have, maybe you took a square of it and you have this attribute maybe x3 which you have created yourself over there. So what we want to do is we want to version and we want to store that metadata of the versioning as well, along with the steps which you are on the data which you are doing. So there are two type of data sets which we have in Azure. The first data set is called as a tabular data set, which you basically have on the left hand side in this location somewhere. Data sets over there, data store, sorry, data, and here we'll have the data sets. So you can get your data sets from the data stores by which data engineers will help you with, and other locations as well. Whatever you want to go for, you can go for that one. So now there are two options, tabular and file, like this. So this is that tabular and file over there. Now this is metadata only. There is no data. This is metadata only. So it becomes a metadata store. We version our data set. We save the versions of them with us for tracking purpose. And in case you want to go back, in case somebody asks you after some time to, or you want to look at what have you done 1 month back and so on and so forth, you can do that. The next thing which comes into place is the repository and your development environment as such. So in Azure, you can use anything. Like you want to use your any location, that's totally fine, totally okay, go for it. So what they have done, in case you want to be more cloud oriented for the experimentation purpose, as such, they have created this thing called as a compute instance, and this compute instance is your development environment over there. So if I take you back, the compute instance is somewhere on the left hand side, and we'll click on the compute option here, and then we'll click on the instance, and you can create your compute instance as your development environment. Okay, now GPU, CPU machines, use them. Git repo of your choice, whichever Git repo you want to use, you go for that Git repo as such. Uh, GitHub or maybe Bitbucket or maybe something else as well, which your company uses, use that. So what we have with us is something over here. If I take you, this is called as dev.azure.com. That's Azure DevOps Portal. And this is where you can also create your CI/CD pipeline. So what you have to do is you basically have to come to this dev.azure.com. You have to sign up over there. And once you, hey, hi, yeah, Naveen, go ahead.
Yeah, I was thinking, could you please refer to the Azure ML SDK functions as well? I see this is just a UI wherein people are just getting started, but subsequently we'll have to automate the whole pipeline. I mean, you can make a note of it and we can discuss later on.
Sorry, come back with your question.
Yeah, for the points which you are mentioning, the visual representation from the charts, you are pointing it to the UI, right? The console UI of the exact
Yes.
buttons where exactly they are located. But in real world scenarios, basically we write codes via the Azure ML SDK. And we would want to
Correct.
see those specific functions from those specific
Correct.
libraries wherein we import those functions. And then we
Correct.
try to automate the whole pipeline through some DAG orchestrator, maybe could be Airflow, or
Correct.
if Azure provides some of their offerings, maybe we could automate those, we are designer, I guess, machine learning designers.
Hmm.
And
Correct.
sometimes we do feature
Hmm.
engineering if the data is drifting a lot, so we automate those
Hmm.
pipelines accordingly, right? And for a
Correct. I
weekly
think
pipeline, monthly pipeline, etc.
right. I guess I'll do two things. First of all, uh, I would like you to go through this one. Let me see if that's the correct one. And secondly, we are going to see that. So hang in. That's the
Okay.
second thing.
Okay.
But
Okay. I was
if
not
I
aware, sorry,
just
of the agenda, total agenda.
right. So I'll share that in the chat once. Let me give me a second. So
Sure, I'll refer that. Yeah.
right, it's one of these links which I gave, but let me see which one was it. The Yeah, sorry, it's the first link itself. I thought you guys opened the first link and you had a look at it. Okay, so this is the in-depth one, the one where uh, you can see the full flow is there with YAML, and where they have. So okay, so what is this? I should have walked us through this. So this is the one where uh, so this is from Microsoft, and what they do is this is a starter project from them, where
Okay.
everything is there in one place, like how to
Boilerplate.
do it for, you can say, for a regression project is their sample which they have taken, but you can simply change it to any other project as well. So I'll share that in the chat window. Is the
Sure.
first link in all the links. Okay, it's in the chat. Now guys, check this out. So if I take you back, so what you need to do is, and I'll open that page again. I'll refer to that page. Okay. So what you need to do is you basically need to sort of, just give me a second. Let me see if I can get it into one page. Okay. There is a bar on the top. I'm just trying to avoid that bar. Okay, so now check this out. So how do we get started with it, right? So we have to go to the Azure portal first. So there is a big scenario in this on this GitHub page. That big scenario I will leave on to you guys to read uh, and do. And there is literally one session which I have already done on this. So which is on YouTube as part of Microsoft Reactor. Few weeks back or months back, I actually don't exactly remember which one was it, but we use this exact GitHub repository in that. So you can look for the Azure, uh, the reactor over there. Now, if I use this, so we have to go and create the dev.azure.com first. There are few variables, for example, which we can set over here, like the base name, location of the resource group, workspace name of machine learning service, uh, ACI deployment. Then after that, we have to connect with the Azure. So this called as service principal based connection. So we do this service principal based connection, and then we use our repositories like this. So imagine this is the infrastructure as code create environment repository, and there is a very nice diagram I want to show. Uh, the Azure MLOps like this. So actually, we are following this one over here. That's what this is referring to. So I think I should just show this one. So you guys, so this is from where it starts. The you can see from this is from where it starts. The data sanity test, the unit testing after that. This is the infrastructure IAC pipeline, the infrastructure as code, which is being referred here right now, which creates your machine learning workspace, the compute instance, and so on and so forth, whatever it is, right? And then after that, we simply, this is where all the steps are there. So the triggers are there, the ARM templates are there. In what's your runner as such? You specify the runner there, and then after that, you go into the more depth, which is there as part of it. Okay, so if I take you back to all of this, I will just take you to my setup, which I have. So we come here, we do the dev.azure.com. We create the project. You can do it from here. Now, there are a few settings you need to do to be able to set up this project. Basically, one thing which I have done is I have enabled the billing over there, because when you run multiple pipelines, what happens? The uh, there are some few things which are free from Microsoft, but uh, because some things are which are not free, your pipelines might be queued as well. So I have enabled this billing from here. How to do it? Please go and check it in this page. It's everything is documented there. Now, the after that, what happens is the Azure Active Directory needs to be connected as well. So this is another step. You click on this, it will be a very big blue button will be there called as connect the directory. We will connect the directory over there. And once we connect the directory, it looks like this. That second thing which I have done. The third thing which I have done is I just made this project, and as part of the project, the Git connection has been done. That's the repository the repo which I'm using as such. So which over here is somewhere in one of these steps over there. We can go and find it. Now, if I go back and if I click on, so this has been done. Some service connections are created. So what this service connection means is we want to create the CI and CD pipelines over there. So this is the CI and the CD pipelines basically over here. So now these pipelines, what they will be doing is they will be talking with your Azure, you can say resources which you have in your Azure subscription. So they need to have some rights over there. Couple of things which are there is we need to refactor the code. Let's say one. Second thing is unit test. The code quality need to be checked over there. So at this point, what happens is that once we provide those tests, there is a setup which we need to do, which is basically called as the agent. So we create few agents over here like this. And on these agents is where your steps will execute. So these agents can be a Linux agent, it can be Windows agent, it can be, you can say, even Mac agents are there. So Mac agents in Azure now, right? So even those agents are there. Okay, so this is the continuous integration pipeline. Now, one thing which we would like to remember is that as part of the continuous integration pipeline, your model will be trained over there. The model which is trained, there is a particular evaluation file which we have, which I have just named here as model register.py, which you can call as any other thing as well. So what this file does, what this py file does, is it goes to the machine learning service over here. If I zoom out, it goes here, it goes to the model repository. It will read the metadata of your previous model from there. So this is where we have the metadata with us. Now, once it reads the metadata, it does a small check. It understands that, okay, is the old model or is the new model which just got trained, is it outperforming the old model or not? If it is outperforming the old model, we will register that. You can have any other logic as well. You may say, no, I don't want to. I want all the model to be registered. You can register all the models. Once you register this right over here, that model registry is basically what you see in this page. So here, this is the model registry. The new one will get registered over there after that. Now, so a couple of you can say recommendations over here. One thing is there are few questions in the chat window. Separate SPN you have created and used in the service connection. I use the default one. There is one option which is called as automatic. Like the first option is automatic. I have used the automatic. I can do it manually as well. But for that, we have to go to the Azure Active Directory, create the service principal, and then get the information, put it here, and go for it. Both are fine. I have used the automatic one, the one which is by default there. Okay, so now this is the model registry. So if the new model outperforms the old model, that's when we want to register that model. Why do we want to do that? Because we don't want to unnecessarily waste the resources which we have, because everything is pay as you go. We have to pay for all of this. there is a very good, nice thing which is called as Open Neural Network Exchange (ONX), which is a project from Microsoft which they open sourced a few years back. Uh, ONX over here. So which I can just show it to you in this way. So Open Neural Network Exchange and the like this. So there are two things which it will help us in achieving in the MLOps pipeline. These are best practices. There are two things which it will help us in achieving. First thing is it will help us in achieving, you can say, independence from the dependencies which are there, which means that if I have trained my model on TensorFlow, in the deployment target, finally, when I will deploy this, I don't have to install TensorFlow dependencies. If it is re-saved or it is converted into Open Neural Network Exchange, then it will be uh, then we just need to install Open Neural Network Exchange dependencies in the production target over there. So it provides independence of the platform. Okay, hang in. So this is one good practice. We can go for it over here about ONX. Now, then comes the CD pipeline. So in this CD pipeline, we have two things: continuous delivery and continuous deployment. I'm pretty sure you guys know this. The continuous delivery will go till here, till this. It will not go till production. So I'll just take it till here, like this. Uh, Maybe till here, like this. And the continuous deployment is going till production over there. So it goes till production like this. So what do we have it? What do we have as production today? Is the IoT Hub over there, where we have already registered our Raspberry Pi as one of the IoT Edge, uh, you can say, device as part of it. So now I just want to show you a couple of things. Okay, check this. Now, how to now? Okay, and before if I can show you, let me just explain this. I have a very nice diagram in my slide, which I copied from their documentation. So I'll just show you that first. Guys, check this out. Very interesting thing. Okay, so this is how it works. That's what we want to do. We have the IoT Hub. It's connected to the edge. That's where the sensors are, right? What we want to do is we would like to create containers. These containers, for example, let's say data collection containers, machine learning service containers, and some alert mechanism containers are there. Now, we would like to containerize and build the Docker images, push the Docker images in a location called as container registry. This location is a service in Azure where we store the images. Then we would like to make the configuration file, deployment manifest file, and then this manifest file we want to push in the IoT Edge device over there. Once we push this there, those images will be, you can say, pulled from the cloud. If I can click on it, like something like this, like that, and they will be running on the edge location. That's the flow. That's what we want to achieve. Now to achieve this, we will go back to the VS Code. To be able to achieve that, we'll go back to the VS Code if I can find that window here. And let me see if I can zoom in. Okay, now there is one thing which I have done, and I extension for IoT. I have installed the extension for VS Code. That's one thing which I have done. I think I didn't copy the link for it. And the link, I am not sure from where I did it. I did it many months back. I'm not sure from where I did it, but I think it will be on this, like that. On this link, you will find it. How to set up VS Code for Azure IoT Edge deployments. I'll put that in the chat window. The mention these steps on the arrows in the diagram. We'll come back. I'll come back onto that. It's a small session, right? It takes time to show all this. Maybe one full day of workshop, right? Maybe we'll organize one for you guys. Okay, now come back and check this. So uh, you should be signed in. I am signed in right now. Then you have to go and you have to click on new IoT Edge solution like this. That's the developer is doing all of this, right? In the development environment. So that's my folder. And what's the name of the solution? So now I'll show you, I'll give you the link as such. What I am showing you is available on this link. That's what I'm showing you over there, right? So it's in the chat window. So please pick it up from that particular link over there. So now we are creating one. We're creating the name of the solution. So let's say custom vision. Custom vision is the name of the solution. What type of module are you looking for? Which language are you working with? Is it Python? So I'm clicking on that over there. Python modules. So this is a classifier. I'll say classifier like that. Face image classifier. Now this I have to go and get it as such. So I have to go to my Azure portal, and I will simply go to this. You see this? I'll show that. You see this location, container registry. I'm going to that. So I'm just going to that here. It's deployed in this location. That's the name, Shivam ACR. I will. I'll get it from there. So it should basically be in the access keys. And let me see what are they looking for. The FQDN basically. We could have typed it ourselves. That's what they're looking for. This one. So let's put that. Let's go back. And let's put it here. Let's put it here. And let me just put it over there. And done. So they will set up the project for me. Now, see, notice this. You see these modules here like that? This module is representing the what we are trying to achieve, and this is also representing what gets deployed as such. So if I take you back here, you see this white box. That's what we are trying to build right now, this white box, and that will be running in the image over there. So if I take you back to the module, you have to come over here, and now this is where you need to put your machine learning code over there. Now, notice a couple of things. I want to show you a few things. That's the requirement.txt. What needs to be installed in your, you can say in that Docker image. We have the Docker files here. This is how the Docker image will be created like that. This is actually the correct location. So for example, the Raspberry Pi, which I have, this one, it supports ARM64 version 8. That one, that's the one. I have to remove the other ones over there. For example, I don't want this. I don't want to keep anything unnecessary. So all of this. The first two were used for Ubuntu environments. So for the device which I have, that's what I need to use. The second one. There is a bug which is going on right now. I tried with this version 8, ARM64 V8, which is the absolutely correct what my version of Raspberry Pi Model 4 Raspberry Pi 4 Model B should support, but there's some bug. So what I had to do is that one is not going to work out, so I'm removing it. This is the one which I am using right now. They're the 32-bit over there, which is not the correct one, but somehow this is the one which is working, which is working right now. There might be a bug in the latest Raspberry Pi, and there is some integration problem. Please go and figure it out. I'm not sure, so I'm using this one over here. Okay, now apart from that, there are a couple of interesting things. So we need to train this classifier, right? Now, if you are using any custom machine learning solution, you will be using the machine learning service to do that over here to be able to do this. Today, what we are doing is we are using custom vision as such. Now, in case you want to do it from Python, which is more suitable for converting into the CI/CD pipeline, the link is there in the links which I have shared earlier. So if I take you to custom vision, this is a cognitive service. It's a pre-built AI solution. So what we do, if I click on this project, you will see that there are multiple options there. Like, are we looking for classification or object detection? So for example, that's what we are doing, but we can also go for this. Is it multi-tag per image, single tag per image? What type of uh, what do you want to go for? Like general, food domain, landmarks, retail domain. So classification in retail domain. That's what I have selected, the compact version. What this compact version does, it gives me the Docker file and the train model as well to be so I can download that. So over here, and you select this and you say create project after that. So let me give it a name. So this is my classifier here, and let's create this. Okay, so now what you need to do is you need to give few images. So I have these images with me, and it's from the link which I have already given in the chat window before. You use it from there. These are basically hemlocks over here. Just give me a second. Let me just quickly. Okay, that's not the one. Let me find the correct location. It's somewhere in a different folder. This is the extra data which I downloaded. I Googled for this data. Let me find the original file for somewhere in my laptop. Okay, I found it. This is the correct one. That I took for testing purpose. So this is what I would like you to what we will use like that. And this are the hemlocks. That's my class. You need actually 30 images to make a good classifier. We have 10 images. Feel free to get more images, right? Uh, do that, and your classifier will be way better than what I have right now. So we are doing a classification between these two classes right now. We have uh, the Japanese cherry and there is a tree, hemlock tree. And let me see if there is a space before it. No. Okay, so these are two classes which I have like this. And then the next thing is over here. Quick training or advanced training. Advanced training will take more time. As you can guess, as such, till 96 hours. This will be better, but we'll do the quick training right now because it will take uh, 4 or 5 minutes as such. So I'll click on train. It will start the model training over here. Now, once the model training happens, I can deploy in the cloud. You see this option, prediction URL. Deploy this in the cloud, do the API call, done. But that's not what we want to do today. We would like to deploy it into the Raspberry Pi as such. So what we do is, I'll take you back to the one which I already trained over here. And this one, and we will click on some of the download options which are there as part of this over here, like this. So how do you want to download this? Like, do you have Core ML, TensorFlow, Docker file, ONX, Docker file? Like this, you will click on this Raspberry Pi 3. Even if you have a Raspberry Pi 4, you use 3, right? Just remember that. As such, the 4 is not available here. This file which you get downloaded, this file I have with me over here, and that file basically looks something like this. So that's that file over here. You see this app code, and in this app code, all the app code is there. That's the Python source file. They give you all these things. That's the Docker file, how the app code needs to be created. Now, what you have to do is you have to copy this, right? You have to copy this stuff. And now I will just take you back to the VS Code, which I already where I did this. And now you have to paste that in the module section. So you do it over there. And let me just minimize all of this. Okay, so in this module section, that's the classifier. You paste it there. So the app file, the app.py, and any other thing which you get, you copy it from there. Anything which is not necessary, remove it. If you're working with Raspberry Pi Model 4, the model B, Raspberry Pi 4 model B, then this is the one which is today is working. The 64-bit is throwing some bugs. Maybe when you will try it, maybe you will not face it. So do that. Okay, now after that, what we do is the input must be coming from one input. You can say from another container which is talking to the camera. So what we need to do is we need to create another module here. This module is basically the container where uh, where you can say the Python container, and this is the camera container, the camera module over there. And this camera module is also going to talk to that ACR, or in that ACR is that where is the image is in the ACR. So I'll just go and get my image from the ACR. I just want a name. I should have copied it. I'll just say that, okay, that's where you are. That's where you have to get pushed and pulled from, like that. So you see one more module got added, the camera module. Now the code of the camera module is in the tutorial which I have given you earlier. You get this camera module code from there, like this, and you put it inside that one. Remove the unnecessary files. We don't need this. I don't need that. Don't need this. Don't need that. And this is the camera module over there. Now, apart from this, when you will click on the deployment on this deployment template, you need to remove some unnecessary things from there. So there is no simulation which we are doing of the temperature. You can do those steps as well. There is no simulator which we are running like that. And we would like the data classify the images camera modules to IoT Hub. Okay, I'll leave this default. Some things needs to be changed. You can look at the code to see how it's done. And finally, once you have done all of this, right, what you will do, you will right click on your on the deployment template, and you will say that build and push the IoT solution to the cloud. Now, what I want you to realize is I can do this from here as well. But if I take you to my DevOps pipeline, and I will just close these unnecessary tabs first. So I don't get confused. Let's see, where is this? So what they have done is they have provided us those same functionalities in the dev.azure.com. So I can search for this over here, and I can say something like that, and I can click on this like this. And if you can see, like build the module images, push the module images, and deploy to the IoT Edge devices over there. So there are three different steps of build, push, and deploy. So and what is the flow? How does it work? As so you will commit into the feature branch, the pull request to the you can say the main branch. Then the CI pipeline will trigger. The output will go in the model registry. That's your artifact which we have, and based on that artifact, which is the module images over there. So I'll just say there's a CI pipeline. Oh, sorry. Over here, let's say this is the one where we are doing the build operation. So then build the image and then push to the, let's change this, and let's say this is push to the ACR. So at this point, what happens? I'll just change this. I have already done all of that. I don't want to change my configuration. Okay. Now, once you have done that, the images goes to the registry. So if I take you back to this, so the build will happen, push will happen. That's the second step, push. Third, this is just basically the manifest file, which is also there automated, but that's the third step where the manifest file will be pushed to the IoT devices, and this is anyways done asynchronously. This part where the images will be pulled from the ACR and will be deployed in the IoT Edge. So in the CI/CD pipelines, they have given us these modules which needs to be used. And if I click on any one of the module here, maybe if I go back, you will be able to see the various files which can be selected. So what I was showing you earlier from there, for example, if I click here, and what I was showing you here manually, this step, the build and the push over there, that actually doesn't need to be done from there. Once you have tested it out, you can specify those path over here. You can simply say that I would like to look for the template files here. So for example, that's the deployment template right now, that one. And this is the third step of the deployment. So I'll just say cancel for now. But once this is done, so I'll see if I have it somewhere in the history. Let me go one page back. Okay. And I think I manually deleted that. Just give me a second. Let me check. Docker PS. Okay. No, not really. Okay. So then once this executes over here, something like this, you will notice that the Azure uh, IoT Edge deployment step will happen, and the image which is built is now deployed. So you will note if you could go to your Raspberry Pi, you can see it some in this way as well. Let's say Docker PS, you will be seeing that the classifier is there and the camera capture is running over there. These two are the custom containers which we created and we pushed. If I take you to my IoT Hub as well, I can show you that it will be showing something like this, that the classifier is running and the camera capture is running over there in this way as such. So what I will do is I will recap what we have done. And before I can do the recap, a very important thing, and there was a question on it, is the data drift monitor as such, right? So what they have done, they have provided the data drift monitor as such as part of the cloud solution. So if I take you to the data sets, and if I click on the data set monitor, and I click on create over here. So what you have to do is you have to provide the source and a target over there to be able to uh, create the data drift monitor, which actually means, and if you want to do it from the code, the link is going in the chat from the code. This is in the chat over there in
Yeah,
the chat.
for some reason, I'm not able to see the chat. Is it
Uh,
disabled for everybody or just for me? I don't know.
I uh,
I can see the chat.
right. Okay.
Yeah,
So
I can see
now,
the chat.
right. Okay, guys, check this.
Okay.
One last thing. Notice this. Very important. Very important. Retraining part over there. So what have we done? If I zoom out, even if you deploy this to the IoT edge, it that's not the end of it, right? Because we have to do the retraining when it degrades. So how do you know it degrades, right? So the data stream which is coming from the IoT edge or from your deployed ML solution, wherever it is deployed, it's not supposed to be only edge as such. Like wherever you have deployed this, that data which we get, we collect that data over there. So in any location, such as like a data lake, let's say a data lake over here, I have the data which is getting collected there. And this data which is getting collected is uh, the target data set or the target data. Target data means what is coming in production right now. So what is coming in production right now. So the concept is that we have a thing in Azure called as a data drift monitor. The data drift monitor needs to be configured. From the code, it's in the chat window. From the UI, it's on this page. It's just like this. From the UI is from here. From there, we do it, create like this. And the code part is in the chat window, right? Both are doing the same thing. Now we choose the target data set over there. Uh, over there. So imagine the target data set is the one which is coming in production right now. That's the target data set over here, this one. And you have the baseline data set. Baseline data set is the one on which you have done the model training as such. So on this, you trained the model. You have trained the model. And this is the one which is coming in production right now. Production data, real-time production data as such. So what this service data drift monitor does on top of it, like this, is it compares the data on which you have done the model training uh, versus the data on which is coming in production. It runs on a schedule. You specify the schedule, how often you want to run it, because it is a cost, and it gives you a data drift. It will specify that how many attributes have drifted from each other. For example, let's say uh, x1 was temperature. Imagine, so x1 was temperature, like this. So when you trained the model, the temperature was having values 2, 3, 4, 5, something. Now, but today, what is happening in production? The same attribute which you have, temperature, it's getting a different value over there. You're getting 23, 24, 25, 26, something like this. So obviously, your model will not be able to handle that, and it will simply degrade in performance. So what this data drift monitor does, it measures the difference between these two and will give you the output in a percentage term, like that, like 2% different, zero drift, maybe 40% drift, and so on and so forth. Once you see the model drift is happening, you will take the call to retrain the models. And the part of the model retraining is which uh, you will take care of that part to trigger the retraining of the model. And that link is what I was sharing with you earlier over here, like this, where we have the model retraining part as well embedded. And this particular, you can see the landing page or the documentation of this is on here. So these are the more to the important links. I have shared them earlier, but you can just note them down again from that point here, and this one over there. Okay, another question in the chat is about the model governance. Okay, and about the risk management. Come back on that. When you say risk management, uh, is this something you were thinking of? The, you can say, the degradation of the model and finding that as soon as possible, or what was in your mind? Come back with the question. Okay, so guys, I'll take your questions now. This is what I wanted to show you. I'll quickly recap what I have explained here, and then we will. I'll just take your questions, and that's what I had for this session. The links are in the chat window for you to follow, and for you to go and
Hello.
it will take you maybe a day to make it end to end. But if I just quickly recap, this is what we are doing there.
Hello, Shivam. Shivam, I have a quick question. Yeah, thank you for your inputs on that model deployment and IoT. I mean, I have a question like, in the model governance, I mean, if you're working upon the model proficiency, degrading and retraining the model and working upon the drift with the data and model, so how we can have the model governance? How can we increase the minimize the risk in production? So there should be some tools, some process should be involved in the production. Otherwise, my business may impact it. So it would be, that's a quick question. And the second thing is I could see the whole system you developed with the Raspberry Pi. Would it be possible to do with the Arduino system as well? Or is there anything, does it has any loopholes and compares to Raspberry Pi? Yeah, I hope my question is clear for you.
Okay, so yes, it can be done uh, with other devices as well. If there is any loophole, I'm not sure if there any bug will come, because in this also there were few bugs which uh, I was I had to work around. Okay, and to the for your first question, let's open this. Okay, so as soon as this loads, so this is how Azure machine learning environment works over here. So this data drift monitor, this is so how do we configure this? So what this does is, in the deployment targets, for example, in your production, you have the model running in a Kubernetes cluster. Maybe in this diagram, maybe we'll have it somewhere. Let me just quickly
Yeah.
and find it. Maybe it is somewhere or no. So let me just put it here. So check this. So this is your Kubernetes cluster in somewhere in the world, let's say like this. And the top is the master node, and these are just two workers over there. Okay. Now, when the deployment is done, this is the image, and this image will have three things over there. The trained model, which is coming from the model registry. So this is the repo of model, and this is where your trained model is there. This one. This is coming from there. And how is this going over there? This happened the CI pipeline like this. Now the second thing which we have over here is the main file, the main.py or the score.py. You can call it anything as such. So when we do the monitoring, here we install the one of the instrumentation key as such. So what this key does, so when this is deployed in the production target like that, over here, what that does, it starts the logging process. It starts logging. So if this is my customer and are sending some data right now, x1, x2, x3, and the prediction was y dash. So that x1, x2, x3 got logged, and the y dash also got logged over here. So this is the maybe a storage account, object storage in Azure, or HDFS data lake in Azure, where we have the data with us, the production data. So and then similarly, on some data, this was also trained over there. And the data rate drift monitor will calculate the risk of degradation over there between you can say what the data which is there right now coming in production versus the baseline data on which we have done the model training over there. So the risk of degradation of model is taken care by this, and that is in the is over here in the custom in this machine learning service. That's the one over here. Now the model governance is taken care over here in this tab. So this is where all the models will be registered, listed. The metadata store will be here. The performance will be there. Which hyperparameter was used for doing the model training? Everything will be there, managed with versions in this tab. So what they have done, this service which they have created, it's not just a machine learning service. It's basically an MLOps service. So if I zoom out, this is how it looks like. So that service is something like this. So we have the versions of the data. We call them data stores, where the data is really kept. That's what we call as data store. The version of the data is data sets over here. The model data store is called as model registry, which is here. You can see multiple ML models are saved. This diagram is coming from a previous session which I have done. Maybe that day we discuss it more. So that's the score file. That's the deployment target, the Kubernetes cluster. And the data rate drift monitor is going to, you can say, versus the source, it's going to compare the destination and will tell the drift in the data. And then it's all on us to do the model retraining. Think about it. Come back with a question.
Yeah, that would be that would be pretty much good. And yeah, I mean, where does exactly you cover the future store? If you want to store the future, and yeah.
Okay, very good question. Azure actually doesn't. Azure machine learning service doesn't have feature store. In Postgres, you have to maintain. It doesn't.
Okay.
Postgres database.
Okay, so if I maintain the Postgres database, okay, so how like I mean, I have a question on that. You know, Azure Data Drift Monitor, still it is not provision in the industry, right? Because I could see that MLflow has a lot of the drift metrics, correlation metric, which will give us the difference from the trained data and the predicted output from the production data. But I could not see like some of the models like the libraries with the Python, PageRank, you might have heard like a stabilization index. So those are the parameters that are relevant and not used in the industry, that many people not used by the, certain projects. Still, it is, streamlining into the some projects we are building in our current project. So Azure, they come with the data drift monitor. But do you suggest any other tool which would be readily available or other than Azure? Because yeah, that's it.
Any other tool apart from this one?
Yeah. Is there an option, Shivam, in Azure drift monitor specifically? You say for you have mentioned some classification, regression tasks, right? Usually that's where we usually get to see in supervised learning. So, are there any AUC, ROC parameters of calculating, or if there is a drift in the? I'm sorry. Could someone please go on mute if they're not talking?
I'll mute everyone. You can unmute yourself. Okay, unmute now.
Okay. Okay. Yeah.
Yes.
Yeah. It's clear. Thank you.
Yes.
So
Yes.
there are parameters for classification. Usually we'll have AUC, ROC, and confusion matrix parameters.
Correct.
And in regression also we will have RMSE, root mean square
Correct.
parameters. And we also have other parameters like Minkowski. And we also have, when you're saying drift, are you referring to just the shift in the hyperparameters? Or you're also including the change in the distribution wherein we try to model it through algorithms, or a complete drift in the transformations at the feature store level, or
Hmm.
you're including everything and
Hmm.
combining it and stating it as drift?
Okay. Okay. So there are three things which you mentioned. Two of them we were referring to. I'll recap it. So okay. Now, first of all, let's say AUC, precision recall, all the matrices, they are more relevant in this point. When we register the model, the new one. So should, if the AUC area under the curve of the new model is outperforming the old one, it's a better classifier over there. So it's going towards one, and the old one was not that towards one. Maybe it was .8. Now you have .5 or something. So let's say the AUC of the new one outperformed the AUC of the old one. So that point was relevant at the model registration time, registration in the repository or the artifact of your CI pipeline. It was relevant at that point. Now, the other 2 points, the feature store point. So what it does is, my screen got stuck. So I'll just see if it scrolls down. Great. So what we refer here is both the other things which you mentioned. So there are two possibilities. First is, this is my Postgres feature store, which we just call as I can call as a data store. It's the location where I'm storing my data. Can be Postgres also supported, right? Like that. So like this. So till Jan, I got the data there. That's my data in that. Now what happened today? In this month, let's say we got new data. So some delta data came. So this is the delta data. The dark color data, this one is what we are calling as baseline, and this is the one which we are calling as the target in the feature store or in the data stores right now. And the difference between them in terms of the drift in the numeric values over there. So here it was 2, 3, 4. Some attribute had 2, 3, 4. Now you have 33, 34, 35. So data got changed. So the data drift monitor will say, let's retrain. So data drift monitor will give us this thing. You can say the percentage drift, like this. Second thing, the data which is coming from production, like this. Let's say this is the production system, and this is coming. It's not in the data store, but it's coming in right now as we are speaking. So this data we log in you can say in a data lake location, and this is the target data set, and then baseline is that data set. So let's say that's the baseline, like this, and the data drift monitor will tell you the drift between the production data which is coming in right now and the old one. Think about
So
this.
are
This
you
is what you're asking.
yeah.
Right?
So are you referring to the difference in the hyperparameters between the baseline and the streaming data which is coming in? Is it?
No. We are literally referring to the data itself, not the hyperparameter. This is the data itself, like the attributes, the spread of the data. The So let's say earlier cyclic data, let's say seasonal data.
Mhm.
Some sort of earlier you had summer data, now you got winter data. It's totally different
Right.
apart.
Yeah, correct.
These
Yeah.
are totally. That's what we are talking about.
Okay. So we are breaking each and every data point into various different features as seasonality, the trends, and the stationarity, and then we are comparing those individual patterns. Is that?
I'll just repeat that. Answer is yeah, sort of. I'll just repeat that again. That's correct. I'll just simplify it. Let's say this is my x1 in the baseline. This is the new data, target data over there, and this x1 is some attribute. Now, original values were 2, 3, 4, 5, 5.5, and so on and so forth. Now the season changed. It's something else. 24, 36, 32. So this is what is coming in production. That's what you trained on. Your model will not perform. It will degrade. The model performance will degrade. So we are talking about the literal drift in the range or the spread of the data on which we did the model training and what is coming today in production target, the real data.
Okay, so
Think
we
about
are
it. Not
rescaling the differencing and we are projecting in the form of a percentage, right?
yes, absolutely correct.
Okay. All right. And then subsequently, when we have this drift, we have to retrain. So I see you're trying to trigger the whole pipeline with the new data, or is there a potential for reinforcement learning options there?
No, it was training full thing.
The
Potential
whole
for
pipeline, is it?
yeah,
I
yeah,
mean,
whole pipeline.
retraining, there are some options which I have seen evolving, wherein they're using the same model, the old model, and when the new data comes in, they are just doing online training, online training, wherein they are just differentiating and trying to adjust those parameters as and when the data comes in, rather than retraining the whole pipeline, because it's going to compute a lot, and we will end up consuming a lot of resources and eventually, you know create a snowball effect on the financial parts.
Correct. So that is not what we are thinking here. That's a evolving field. If it comes up and becomes the de facto way of doing it, it will be there. But it's not possible in all the different algorithms or the frameworks which we have. So no, it's a normal retraining of the model, triggering of the pipeline, not the online training, not the delta training which you are thinking of. No, this is not that.
I
That's
was
applicable in
referring to the RL ops, reinforcement learning operations,
yes,
just a
correct.
little drift, that's it.
Yeah. That here is that's this is not that. No,
Okay. Okay.
it's a normal MLOps
Um,
pipeline. Yeah.
would that add margin optimization in terms of bills? Do you see that but potential there?
Sorry, come back with the question.
Yeah. Do you see margin optimization, improvisation through RL ops? Is there a potential, do you see, from a mathematical and a computation and financial standpoint?
If it comes up, let's say if we are able to do that in every different, let's say in transformers, in let's say deep learning, classical machine learning, which is a
Mhm.
very long shot because it's mathematics. It doesn't work like that because if you practically think it through, if you think about deep learning, even
Mhm.
if you get new data, you have to adjust all the parameters, right? Because of the way it's not a transfer learning we are thinking of. Transfer learning is a different concept
No,
altogether.
transfer is different, just the
It's a different
basic
concept. So
features. Yeah.
if your data drifts, if your data changes, adjustment needs to be done in all the you can say all the parameters on all the nodes, all the neurons as such. So I don't have any you can say smart answer for it. If it comes up, great. It's a promising field, uh, but that's
Okay.
not what's happening today.
Okay. Have you heard of A3C agent algorithms?
Uh,
Asynchronous actor critic advantage,
no,
which
no.
Google is innovating now. I'm not sure whether that is getting offered already by Azure. I was just trying to explore if that option is there. I would just go ahead and click that option and reduce my, effort of performing that research on that.
Okay. No, it's not there.
Okay. Okay. So let me put in something. Yeah. Thanks.
Hi,
Yeah,
Shivam,
Shivam,
this is
thank you.
Anish here.
Yeah, sure. My quick question on that. Yeah, sorry. How you are carrying the model testing part before we train the model? Are we writing any test cases or how it's
Yes. Okay. So the model test cases will be over here. So you can say this is the way the model gets built. Now somewhere over here is that step will be there. Let me just put it here like this. So we are comparing them. You can say we have some sample data. Let's say this is a sample data, or there's a test data. Let me just put test. Let's say test. The model got get built. Uh, the test cases are there, and if the new one outperforms the old output of the test cases which were in the uh, model store, that's when we are you can say we are registering it. Now the
okay?
second part, how to do it, that one is the link which I gave earlier.
Yeah,
I
I got
haven't
it. I got it.
that link.
I got it. I seen that. Yeah. And regarding this, can be integrated with the CI pipeline, or do I need to write a separate test cases to integrate? Because normal CI/CD fashion, the engineer person has to test, but Azure has that integration too.
Come back on the question.
I mean, Azure has that any tool to integrate with the model testing?
Azure DevOps can no, there is no separate tool. Uh, there is no separate tool, but in the DevOps, see, model testing tools are not. We don't have any tool like that. We will do it with. We have to write it. Uh, we have to script it out.
Okay, I got it now. Yeah, thank you.
So,
Thanks for the input.
Shivam, this is Anish here. I have a very quick question. Is it
Yes.
possible to have the learning distributed or federated learning is possible? Because I'm looking for some options where I could do the learning on the edge side rather than doing it on the central side. So
On the edge, you want to do the model training, right?
the training and and something like a drift monitor running on the model side. And if there is any change in if there is any the data gets dirty, so that the training should happen on the edge side. And then the train model, the whatever the differential data should be transferred to the central side. More about more of like a federated learning kind.
Interesting concept. For example, let's say you want to train in the customer's browser because customer data cannot be taken to the cloud. It will breach the privacy. But there is nothing
Absolutely.
which we have to do that. What we will be doing is uh, you need a very powerful device to do this. Uh,
Yeah.
there is
TPU,
nothing in
I
Azure.
guess. Yeah.
Yeah, there is nothing in Azure which is for this purpose. But
Okay.
we can. But let's say hypothetically you have a very powerful device. You do the model training there. Great. Uh, we can uh, the data if the data gets dirty, this device will be like a server over here like that. We
So the
can do
data
it.
is not data is more like a numerical value. So it's not a very the image kind of data. It's more like a temperature, the humidity, and so fine. And then there is some actions that's been taken locally. So it does not require a very high data to even train the model. So that's what we have done in RPI itself to check if the training can be done, and it was possible to do the training for 1 years of data into it, and where every 15 minutes with the 20 to 38 parameters were that features. So it still works well on the RPI. So and 4 GB will be great to have that it could be done. So I'm just thinking if we have this requirement, we need to actually have the federated learning because the customer is saying the data cannot be transferred to the centralized server because of the data privacy issue. There is some retail data involved in it.
there is nothing specifically in Azure, but we have to custom create the solution. So let's say something similar to what we were thinking of. So this is your edge device over here, or the laptop of the customer, or his mobile app or something. So their model is training itself on the data which is getting stored uh, locally. I'll show you one thing which is very interesting, and it's for you only. Uh, if I click on this option, I can click on that option, and I have to just give me a second. 1 second, or let me go one page back. So we can get it done, but it's going to be very custom. And I'll just show you something which is for you. So if I click on this, and if I click on set modules, now let's say if I click on marketplace modules there, so these are running in that over there. So if you want a SQL database here, let's say in the edge over there, or an object storage in the edge as such, then that is available as Docker containers. So I'll come here, I will say SQL, and I would like to like this Azure SQL Edge. So if it was relational data, that's where the data store was in the edge, and even object storage can be pushed over there uh, as such. And for your data, let's say for your cleaning of the data or for constant analysis on the data, we have stream analytics solution for the edge. So it will be deployed and it will be running over there. And the object storage is also available if you have unstructured data and you want to keep it. So it's called as Azure Blob Storage, which is object storage for the edge itself. So this is a very lightweight module. It will run here in a Docker container, and but this device has to be slightly, you can say, high performance device. Should be having a lot of resources. Yeah, can be done, and it can be done with Azure itself, with the Azure IoT solutions itself.
Only thing is that once the train model has been created, now that model has to be transferred to the centralized, and then it should also have the centralized training only with the help of the model rather than with the data. And then you will build a final trained model for other locations. So this will be transferred to the other location. So without the data has been sent to centralized, this is basically a concept of federated learning, So that's what we are trying to implement, and we are actually doing it on our own. So the complete coding, rather than if we can use something from Azure or GCP directly, that would help.
No, Azure doesn't have that yet.
Anis, I guess the A3C agent algorithm will fit the bill. That's already available in reinforcement learning. It is asynchronous actor-critic model wherein it will deploy the training models in various different containers asynchronously in parallel in the same device itself, and it will retrain the model with less computation resources. You don't need huge TPU resources there. And that is usually performed in Rust language. And Rust is actually catching up a lot of attention. And if you're aware of the AKS service, Azure Kubernetes Service, Azure has tied up with the Rust community who has started on their journey in Mozilla. And through the browser, they will actually take that API request and they will utilize the same resources inside the Raspberry Pi or the Arduino or any of the other devices without sending the data to the cloud. They will use the same data and they will just retrain and they'll put another model in front of the existing model, so that the data will flow through both the models, one after the other, so that the correction happens in the second model there. You got it, right?
Okay. Yeah, but still it is not having the with the help of the model, we can be transferred to central location without the data.
Data will never go out.
Average federated learning could be done on the server side only with the model rather than with the data.
That will breach the privacy. The data should never leave the device. The training should happen inside.
The model is leaving the device. The model goes from the device
to
the
model should not even leave. There is a new level of privacy which is coming in extreme privacy cases, wherein the model should not also leave, because when you're sending the model, you're sending the whole distribution of the data, right? And that is a much more higher risk. So
That
we
would
will
be on the
never
customer.
send the model also.
That would be on the customer's central location itself, but it needs to get transferred to the another site. Since it's an IoT thing, you need the same trained model across the country or across the globe. Okay, anyways, so if this is not supported by Azure, so
Yeah,
I would
Azure
not
it's
like
not
to,
there. As far as I know, if Shivam knows about this, yes, we can discuss it.
No,
yeah, we
it's
can
not.
connect offline and discuss it. Okay.
Right? Correct. Yeah, it's not there. Okay, so I'm
Yeah.
uploading this diagram. Anybody who wants this diagram, which we were working on, it's going in the chat window. Click on it, and we will. You can download this one, which we worked on. Okay, so now,
Shivam, I have a quick question. Not a question,
yes,
actually, a request.
yes.
Okay. I see a lot of pros here, but I'm a beginner. Okay, and I really most of the things are like bouncer. But I want to ask you, if I am a beginner, what are the very basic things I should be comfortable with to be able to holistically understand this space and not a skewed understanding. So please guide the beginners towards that at the end of the session, and give the links and whatever things you would like to share, so that a person can get started in this space properly. That's all.
Correct. So
Thanks.
thank you. So we are already half an hour over the time, so we'll be winding up now, and I will give you the links now. So this is called as MS Learn. If I go to MS Learn and if I search for maybe MLOps over there, for the learning path of MLOps is somewhere here, this one. So it's around of 2 hours, but this is just the MLOps part of it, where DevOps comes into picture. And those who are beginning with it, uh, I'll give you one more link over here. Let's say I click on browse, and I will say, mm, I will search for machine learning here. You can also search in that like that, and go to the beginner. And if there is a learning path available, that's the best, and they have a lot of them. So that's the PyTorch learning path. This is TensorFlow learning path. Uh, and then these are some specific to Azure. So you can IoT Edge. That's the learning path for Edge engineers. This is the MLOps learning path, the proper one, of 17 hours as such. So it will take some time to go through that, but this is absolutely, you can say it's very good. Oh, sorry. So this will cover it from scratch to the absolute end as such. It covers um, everything over there like this, right? So this link is also going in the in that sheet. So everybody, please, I'll give these links in the chat. Go through them, and whatever we have discussed is also coming from there, and that's how you can get started.
Thanks a lot.